What it do, E-World? Crisscrossing wires. And we're going to do a hall sensor replacement in this RZ motor. Now, I accidentally blew a hall sensor the other day, and I'm pretty sure I believe I know why it blew. And that's my fault, because when I disconnected the Cyber X battery, the bike was still powered on, right? When the controller was powered on. So when I disconnected the battery, you know, you could see the energy diminish out of the controller, and the display just faded on out. Normally those controllers store a little bit of charge because there's capacitors in those controllers, and actually that's what the pop sound is when you connect the battery back up to a controller. You hear that pop because those capacitors that's in there, they store a voltage, and because the voltages are different, whatever's remaining in the capacitors, when you connect the 72 volts back to it, you know, it may have drained down to 12 volts somewhere. You know, there's a voltage left in the controller. So when you connect it back to 72 volts or whatever, and it's that huge surge, it makes the pop sound. Now, because I didn't power the controller off, if I were to turn the key off or powered the controller off, this wouldn't have happened, because the controller would have stored that charge, would have still been, some of that voltage would have still been in the controller, okay? But because I disconnected the battery with the bike powered on, and it slowly discharged out of the controller went flat all the way to 0. So therefore, when I put the new pack back in here and initially connected the power, there was a huge surge because of the way I, you know, disconnected the pack. And if you happen to have cheap hall sensors, you know, non-premium hall sensors, like what's probably in that motor, because I'm not sure if that's a QS motor or not. It's just probably some random motor. Let me see. Do I have? I got them in here somewhere. I gotta find them though. But I have the Soul hall sensors that I buy all the time, and they're pretty premium. Oh, I know where I put them. Anyway, I'll get them later. But yeah, the ones that come in the inexpensive motors, and like I said, I'm pretty sure this is not a QS motor, because it only comes with one set of halls. You know what I'm saying? Most QS motors, like this one over here, it's a QS motor, always has a reserve set. See, there's a reserve set. Just like this QS motor down there has a reserve set. You know, QS puts in a reserve set, and that's great. That way you ever blow your hall sensors. And like I said, there's different reasons for why hall sensors blow. Normally it's because of you know, a surge of current like that, or sometimes running extremely high voltage will knock a hall sensor out, or I've seen a lot of hall sensors blow from too much e-brake. You know, for some reason, if you're using a lot of e-brake, that tends to knock hall sensors out. Like I said, if they aren't the premium ones, and the motor's hot or warm or whatever. I mean, there's different reasons why you can knock a hall sensor out. They're pretty sensitive. You know, hall sensors are just little transistors, field effect transistors. They're very small. They have a very low current rating. See if I can put my hands on them. If I can remember where the hell I got them at right now. I had to dig for them, but I got some in here. And these are on a circuit board. Now some hall sensors come on a circuit board like this. There's one missing right there. But these little field effect transistors are actually the hall sensors. You notice they have like a heat shrink on them. If they don't have heat shrink on them, there's 3 legs to a transistor: emitter, base, and collector. All right, now those 3 legs are very close together. I gotta remember where the hell I put my damn new sensors at. Man, what did I do with them damn things? Oh boy. Sorry about this, guys. Okay, here you go. I got some more. I got another set around here too. But anyway, okay. Hold on. Let's see if I can open this bag. Damn, I forgot that's over there. Okay. This is a hall sensor, alright? It's a little transistor. Their transistors are either NPN or PNP. We're not going to go too deep into that, but that's how transistors come. And like I said, 3 legs on them: emitter, base, collector, or collector, base, emitter, depending on whether it's NPN or PNP. Alright, I believe these are NPN. But anyway, as you can see, I don't know if you can see that, but transistors have to go in a certain way because, like I said, because of the 3 legs that's on them. And if you put it backwards, obviously you would have the emitter, base, and collector mount, you know, in the wrong spot. Now, like I said, some motors, like this motor right here, this is a cheap Chinese motor, off-brand. They're all Chinese, but a cheap motor. Now, a lot of inexpensive motors, this is like one of the no-name 1500 watt motors. And the no-name low power motors, like the 1500 watt and the 3000 watt motors, they will normally have this little circuit board like this. And let me see, where is the okay, right here for the hall sensors. Right there, if you can see, 1, 2, 3, that's where the hall sensors go. If you can see those little openings, I don't know if that's showing up, but they stick in there like that. And like I said, one of them is missing. And as you can see, they fit right into those little slots. They only fit one way, so you actually can't put them in upside down the way the little slots are carved. You actually can't put them in there backwards. But I imagine you could, and just don't put it in the slot properly. But anyway, when they have this little board like this, normally it's glued down. They have like some silicone glue on the coils, and it'll be glued just like that. Now, notice hall sensors have 5 wires on them, and 3 are the same as the phase wires. You always gonna have a green, blue, and yellow phase wire, so you'll have a green, blue, and yellow hall wire. You'll also have a ground, and you'll have a red, which is your positive 5 volts. Obviously, these hall sensors need voltage to operate, and they operate off of 5 volts, so you need the ground as well. Okay, now you can get an Ebike tester from off of Amazon, and they're really nice. I don't have mine because I let somebody I loaned it to somebody, so I don't have mine right now. Let me just pull one up so you can see what it looks like. And they're very inexpensive, like under 20 bucks. Ebike tester, testing device. I know you guys have seen them before. They look like that. These little white boxes, Ebike testers, and they got different connectors on there. They have one connector that's input side, and the other side, well, controller and motor side. Now you also can check your controller. If you plug the side up to your controller, you want to make sure when you testing your controller that it's switching 5 volts between the blue, yellow, and green, and they do that in sequence. Also, when you test the motor, you plug up, and the way you test is these Ebike testers, like I said, they provide 5 volts just like I just told you, and you connect it, you turn the power on of the Ebike tester, and then you just spin the wheel backwards. As you spin the wheel backwards, there's 3 lights on these Ebike testers. All right, if you can see in the picture right there. And what'll happen is, if it's working properly, those 3 lights will change in sequence. They will flicker. Blue, green, yellow, blue, green, yellow, blue, green, yellow. If it's one of the hall sensors that's not functioning properly, it will either stay lit solid red, or it won't light at all. So let's just say maybe the green and the yellow are sequencing and the blue is not, or the blue is staying solid while the green and yellow are switching. So, you know, like I said, if it was switching green, blue, yellow, it's working properly. Now, if you don't have an Ebike tester, you can do the same thing with a multimeter. You can take your multimeter and put it on a scale where you can read 5 volts, normally like the 20 volt scale. You're going to put your ground into the ground, and you're also going to put, and this is while it's connected to the controller. You need to have it connected, your hall's connected to the controller so it can get the 5 volts. So you're also going to test and see if your red wire is getting 5 volts. Because if the red wire is not getting 5 volts from your controller, the hall sensors can't work. Now, once you test and determine that the red is getting 5 volts, then you can leave your ground probe stuck in the ground, and you're going to stick your red lead into the yellow. When you stick it into the yellow, you're going to spin your wheel backwards. You'll see the voltage change from 0 to 5 volts. 0, 5 volts, 0, 5 volts, or it'll be a low voltage switching, like it might be like a half a volt to 5 volts, half a volt, 5 volts. Long as it's alternating 0, 5 volts or low 5 volts, it's working properly. Then you do the same thing with the green. Then you do the same thing with the blue. As long as you're getting a low voltage or 0 and 5 volts, they're working properly, okay? But like I said, these Ebike testers are nice because they have the connector on there that fits the halls. Like I said, it'll fit the controller side, it'll fit the motor side. What it also has is, you see those alligator clips right there. You can also test the phase wires on the motor. Connect the green, blue, and yellow to the motor, along with the positive and negative. And when you spin the motor, the phase wise, it will do the same thing like the Halls, green, blue, yellow. The lights are changed. And you can also test the phase wires coming from your controller. So you can test the Hall wires and the phase wires with an Ebike tester. And like I said, do the same thing with the multimeter. All right, so that's how you test Hall sensors. All right, now I'm gonna go ahead and I'm gonna start. I already started taking the screws out from around the side of the motor. Now I left these two here because this wheel, one thing nice about these electric motorcycle wheels, they come balanced already. And the way they balance them is, I don't know if you can see, but there's a weight right here. It's actually two of them stacked on top of each other. This wheel has been balanced and they put the weights right there on these two screws. So what I'm going to do is I'm going to mark it, because when I put this cover back on, I want to put everything back at the same spot, and I want to put the stator back in exactly the same as well, so the motor will still be balanced. What I'm gonna have to do also is I'm going to turn the axle. Right there you see my torque arm. I'm gonna have my torque arm pointed to that screw right there, so that way, like I said, when I put it back together, it will still be balanced. If I don't turn that stator, or have that torque arm pointed to right there, it's not going back exactly the same. You know what I'm saying? It could be something, depending on where the Hall sensors are in this motor, that little bit of weight can throw it off. It's just different weight from the coil wire. It could be anything that's changing the weight. So you want to make sure you have everything goes back exactly the same. That torque arm pointing to that bolt, and the weights going back right there. All right, so after we get this apart, I'll be back. All right, so after we got the covers off of that motor, I started looking at it. Originally when I had glanced on it at the bike, not really paying attention, I wasn't sure if that motor circumference was equivalent to a 205 or a 273, but now that I have the actual wheel off the bike, it's obvious that that circumference is the same size as a 273. This is the circumference of a 205, and as you can see, 205 is a lot smaller than a 273, even though that's not actual 273, but it is the same size as a 273. So basically it's a 273. It just doesn't have the phase wires and windings for it. I need to measure the width of the stator and the height of those magnets to determine, is it a 40H or a 50H, because it doesn't say. At least I don't think it did. No, but I can easily measure the width of that stator. As you can see, here are our Hall sensors, and just like I said, normally the more inexpensive regular motors, non-QS motors, tend to have that circuit board in there, like the other one that I showed you, this one right here, except that came out of 205, so it's much smaller, the width, but it uses that same circuit board thing. Now if you can look at a QS motor like that one right there, hopefully that's coming through. You see the QS motors don't use circuit boards, they're wired directly straight to those transistors, see? And all they need is 5 volts, ground, and whatever color hall pertaining to the phase wire is. Now this is the opposite side. This is the reserve side. So the reserve side has white, gray, and purple. But on the other side, it has blue, yellow, and green. And like I said, QS motors, they give you a reserve set. Now, these economy motors only give you 1 set. Now, you know, it should be standard that all motors give you a replacement, you know, a reserve set. And normally the reserve set is on the opposite side. So, one set, the blue, green, blue, and yellow on one side, and on the other side you have the purple, gray, and what's the other color? Purple, gray, and white on the reserve side. Now, I'm not going to bore you to death with showing you step by step. I don't think you need to see that. It's pretty, you know, it's time consuming, so I'm not going to have the camera rolling all that time. But what I'm going to have to do is, this is silicone. This board is siliconed onto the coils. I'm going to have to pull it off. It will pull right off. It's like that silicone is real soft, like rubber glue. Pull it off. Then I will have to desolder these transistors. Put the new ones in there. Now, even though there's only 1 bed on here, because I'm going in here, I'm not going to just replace 1. And being as though these are premium Sewell hall sensors, a better quality hall sensor, I'm going to replace all 3. You know, why go in and just replace 1, even though it's only 1 bed? You know, like I said, these hold up a lot better. I think they have a higher current rating. You know, not much. These are very low current transistors, field effect. But I think I explained in another video how they work. You know, when these transistors are energized with 5 volts, they respond to magnetic fields. So the magnets, the permanent magnets, go around the outer, you can see them. If you look in there, you see them. They're glued to the outer frame of the hub. And as the magnets spin around the hall sensors, each time the magnet goes across, you know, it allows these transistors open and close. They're like a switch, but it's a switch that's activated by the magnetic field. So as soon as a magnetic field passes in certain proximity to that transistor, then it closes the circuit. Open, close, as the magnets rotate. Okay, and as they open, close, it's 5 volts, 0 volts, 5 volts, 0 volts, 5 volts, 0 volts. All right, now, because there's 3 of them and they're spaced apart like that, these sensor wires, the hall sensor wires, go to the controller. The controller is reading, all right, it's going to be, this is yellow, blue, green. Inside the controller, because it's smart, the circuitry, it's sensing that the yellow is getting 5, you know, it's switching 5, 0, 0, and then it's 0, 5, 0, 0, 0, 5. All right, and it's sequencing, like I told you, 5, 0, 0, 0, 5, 0, 0, 0, 5. And the controller is reading that as the wheel spins, no matter how fast it spins. From that, they are able to determine the RPM of the motor and the direction that the motor is spinning, and also the position of the motor, you know. So it's a lot of information that's acquired just by these transistors switching, you know. Transistors have various things that they can do. Well, basically they either act as a switch, electronic switch, high, low, or they amplify. Most of the time transistors are amplifying signals. So like in car stereo amplifier, they have transistors, MOSFETs, that boost power. So if you got 2 milliwatts in, you might have 200 milliwatts out. Normally that's what transistors are doing, amplified. Now high power transistors that amplify, they get extremely hot because they're producing all that power. Normally they have like a hole in the middle, and you're able to bolt them to a heat sink. They're normally bolted to a heat sink and have silicone heat transfer grease in between. Okay, so if you open up a controller, the MOSFETs inside, big high power transistors. And I'm going to see, my next experiment is to see how much power this motor can handle. All right, the stock RZ motor. And I am going to upgrade the phase wires. Now, being as though I don't have a set of them to run all the way to the inside, what I am going to do is I have another motor like this with this size phase wires on it that's I'm not using. I'm going to steal the phase wires off of it. Now those phase wires are too thick to run all the way to the inside of this motor, but what we're going to do is run them as close as we can to the motor. So right outside the motor, I'm going to attach that heavy gauge wire to that 10 gauge wire. Now, is that optimum? No, because it's not going all the way to the motor. However, by having that heavier gauge run that distance with thicker gauge, it's going to still supply more current than these phase wires that run the entire distance. All right, so it's only going to have to go through that gauge maybe about 3 inches instead of the entire 4 foot worth of cable. You know, the longer a wire, the more resistance. Okay, so the shorter the wire, the less resistance. The thicker the wire, the less resistance. Now we're going to run thicker wire all the way right up to the outside of the motor, and that's going to be not 100% improvement, maybe about a 65% improvement, but an improvement nonetheless. All right, deuces.